So I wanted to practice some log and exponent equations. Let me do exponent equations first because I actually think that's harder than the log equations. Yeah, this is a review. We have more stuff to learn, but I'm just want to review midway. Yes. So let's first do an exponent one. Let's do something simple. Let's do like 3, 1 minus 2 to the x.
Wait, when's the test?
Equals, it's a while, so it's 20 second. Because before I figure out what's the next thing to teach you, I want to make sure we have this down. Okay. In this situation, I want to solve this, and I don't want to use logs.
Wait, what's it called?
This one will be exponential equations. That doesn't need log in this case, I guess. Today's a review, so I'm reviewing the last 2 lessons, okay?
Exponential what?
Exponential equations.
It's like the homework we had from like a few nights ago.
This will be 2 nights homework ago, and then the next thing will be the nice homework ago. All right. So this one over here is 3, 1 minus 2x equals 243. In order to set this to work, I need them to have the same base. Always you want to figure out how can I reduce the base down. I'm always reducing the base. So in this case, I want to figure out, can I rewrite 243 in terms of power of 3? In this case, because I'm making up the questions, yeah, you can. So I can rewrite 243 as 3 to the 5th power, because 3 to the 5th power is 243. So if they're equal, it's totally allowed to swap. Because the base 3's match each other, what that allows me to do is cross out the base 3's on both sides, which means all I have left is an algebra 1 equation. 1 minus 2x equals 5. A little bit of algebra. X equals negative 2.
Why are you so like I know it's because they're equal, but you're saying like get rid of bases. We never did that before.
We did do that before, and the reason we could do that is because what we technically do is do log base 3 on both sides. Because we're doing log base 3 on both sides, the whole 3 cancels out, which is why we want them to match, so we don't left with a log. If we're left with a log, that's more annoying. Another example. This is an interesting one. 4, 2x plus 3 equals 1. Now, to think about this one, 4, 2x plus 3 equals 1, what we can do is think about, usually we reduce down, but what causes anything to become a 1? What power?
0.
0. So this is the same thing as saying 4 to the 0 power. Because 4 to the 0 power gives you 1. Wait a second. 4 on bottoms. Cross that out. 2x plus 3.
The bases have to be the same, and then you can cut them out.
Yes.
Why is that? Why is that possible?
Because what you're technically doing is you're doing log base 4 on both sides. And when there's a log base with the normal number, they cancel out. That's what you're technically doing. Mathematically, all you do is cross them out.
So can it work for like in general anything with exponents? Like if I have 4, and
I'm making them very particular so they do have the same base. If not, you're forced to do logs.
got it.
But I'm making them, or this worksheet is very particular in this way. Okay.
How many more lessons do you have?
I want to figure out what kind of lessons because I have to do a interest lesson, and then probably that'll be it. So I don't know if I'll start chapter 5 early or something like that, because our test got delayed basically 3 days back, which is very far. If it's 1 day back, I want to add something. 22nd.
Wait, you didn't delay it? Right, or she chose to delay it?
Yeah, Rabbi Hershey chose it. Huh? What's up? It was supposed to be this Thursday, which means I would have been happy with what it was, we already learned. You probably have, or some people have other tests during that day. Exactly. Go ahead.
It's just practice, right?
Yes.
So I already have some of my notes.
I got you. Yeah.
Yeah?
Yeah.
Okay, come.
All right.
Actually, I'm listening. I haven't listened to it.
Why?
My birthday the day after the last.
No. Next one.
Don't say.
Let's do this one. 3 negative 2x plus 1 times 3 negative 2x minus 3 equals
It's the same.
3, negative. This is the same category, if that's what you're asking. Put that a little bit to the side. All right. Now remind me, when you multiply something with the same base, what do you do to the two exponents? You add them. So that means I could put these and add the exponents together because they have the same base. So 3, negative 2 plus negative 2, negative 4. And then 1 plus negative 3, negative 2.
We've been doing this in class.
What's up?
We've been doing this in class.
I don't know if we did exactly this type of problem, but combining is an old skill.
I'm saying I know we all with like the logs and stuff.
What do you mean?
Like I haven't really been paying attention that much, but like the parts I haven't paid attention. That's probably why.
The logs is the second half of my review today. That's why. I'm dealing with exponents first, and then I'll do logs.
Like this is like the earlier part. Yeah.
This is what we learned Thursday, and then I'm later going to do what we learned Friday. I just want to practice that itself. Then we'll have a day practicing the early stuff, which was like condensing and expanding. Okay, with that in mind, because they're both 3 on the bottom, I could cross them out. Negative 4x minus 2 equals negative x. A little bit of algebra.
X equals over. No.
X equals negative 2 over 3. Nope. Yeah.
So, no, I got x equals negative 2 over negative 3, which is that cancels out. Negative 2, sorry, 2 over 3.
No, yeah, because you bring it over, it'll be a positive 3.
Oh, wait, negative x doesn't.
You want me to show the algebra?
Why can't you divide the?
You just
Do we have to
add
get the right
4x
negative?
on those.
Wait, one question at a time. Gal?
Why don't we get rid of the negative first? The negative attached to the x.
Well, what I did is do plus. I did plus 4x on both sides, so I get negative 2 equals 3x. Remember, I liked moving the smallest x, and the smallest x is negative 4x. And then divided by 3.
Divide the negative out.
You could have, yeah.
That'll make it
Everything should be positive, though.
right.
I don't-
4x plus
2 equals x.
Yeah.
And then you subtract 4x, which then you're going to get negative 3x on the right.
negative 3x, right? So negative. So, oh.
Yeah.
I see. I remember thinking of the negative.
Mm-hmm. Shelby, you had a question up there?
No, I didn't.
Let's do another one. 64 times 16 to the negative 3x equals 16 to the 3x minus 2.
Does it say like 4/3 or 4/3?
Say that one more time, sorry.
Is that like for the problem, the answer? What is it?
Negative 2 over 3.
So
My fault. All right, next one. 64 times 16 to the negative 3x times 6 equals 16 to the 3x minus 2. In order to make this work, I need to change them to the same base. First, I check 64. But 64 cannot turn into a power of 16, which means now I need them to make them a similar base to everything. You technically have 2 choices. You could change them all to a power of 4 or a power of 2. Whatever you're more comfortable with, it doesn't matter. I'm going to change it all power of 4. So I'm going to change 64 to 4 to the 3rd power. I'm going to change 16 to 4 to the 2nd power, negative 3x, because I need them to be all the same. You could also have changed them all to the 2nd power. If you did that, you will still get the right answer if you change them all to the 2nd power, assuming you did it right.
Wait, what do you mean? What do you mean?
You could have changed this to 2 to the 4th power, or 2 to the 6th power, 2 to the 4th power, 2 to the 4th power. What's wrong with you? So then 4 to the negative 6x equals 4 to the 6x minus 4. Remember, you distribute technically to these things. All right, combine like terms. 4 to the 3rd times 4 to the negative 6x. You add them together, but they're different terms, so you can't really actually add them together. You just put them next to each other. Negative 6x plus 3. If you wrote 3 minus 6x, that's totally fine.
Wait, why can't you actually combine them?
because this is a 6x and this is a normal 3. They're not like terms. All right, 4. So then 4s are on the bottoms, cross them out. Negative 6x plus 3 equals 6x minus 4. An algebra 1 problem, plus 6 plus 4. You get 7 over 12 equals x. This one will be exponential equations. And then one more before I go on to logs. I'll just put it right here. Just a reminder, if you're left with something like this, let's say 1 over 4 x equals, let's do 8 to the 2x plus 1. If you're left with a fraction, you have to use a negative exponent to naturalize the base. So this is going to be 2 to the negative 2 power x. It's a 2 power because 2 to the 2 power is 4, and it's a negative because it's a fraction. 2 to the 3rd power, 2x plus 1. 2 to the negative 2x equals 2 to the 6x plus 3. Cross those 2's out. I'm sorry, I'm trying to like save space. For no real reason, actually. Let me just scroll down. And then minus 3 on that side, plus 2 on both sides. That'll be negative 3 over 8 at that. All right. So that's exponential. I'm going to do logs next. Plus 2x on both sides, and then a minus 3, then divided by 8. You could do minus 6 on both sides. You get negative 6x, or negative 8x, and then divided by 9. You got to distribute the 3, yes. All right, I'm going to move on. Yeah. All right, next one. We're doing log. This is going to be under log equations.
How many sections are going to be on this test?
I'm going to do tomorrow. I know what I'm going to do. I'm going to do the word problems, like the interest, the compound interest thing.
Is everything else posted?
Everything else is posted.
Is this your, I don't know, I was thinking out. This is your question.
This is going to be, let's say, half of the review, basically, as one video. Okay. All right. So this is log equations. So kind of like exponents, if you have the same logs on both sides and they're all in one thing, you can cross them out. And then it just turns into an algebra problem. 5x equals 2x plus 9. It's log based. Oh, the base of the log is the same. So no little number. You know, base 10 in this case. Yeah.
What do we call the number next to the log?
That's just what's inside the log. It's like you don't call anything the number inside the sign anything or inside a tangent.
The thing on the calculator, basically, not the thing below it, but the thing on the parentheses, you're saying.
Yeah, there's just the number inside the log. They don't have a special name. Log equations. The last one, exponential equations, is log equation. So if the log is the same on both sides, is actually the easier question you're going to get this year, right? It's just algebra 1 with an extra step in the beginning. But guess what? Not always are going to be a log in the front. So let's do this one.
We're gonna have still more reviews, right?
Yes, because I'm not covering everything in this. But I'm not covering everything in this. Tomorrow we're going to...
You will cover this like in a review, right?
I mean, I'm recording this one, so I might not.
This is recorded?
This is being recorded.
No, I'm saying because our test is still like far away, so like, aren't we gonna do one more?
Probably, yeah, for sure, for sure. We'll have another review day eventually. All right. Shh. This one, negative 2 times log base 5, 7x equals 2. Before I can get rid of a log, I need to get the log completely by itself. So what could I do with this times negative 2?
Move it to the other, the top,
The other side by
other
what?
side, and then make it the
Before I do that, I know what you're saying. I got to divide negative 2 on both sides just to get rid of this 2.
Oh, okay.
So then I'm log base 5, 7x equals 2 divided by negative 2, negative 1.
What's the equation would be then that if you have a number next to y, if you move it as an exponent? Like
You could do the exponent. You actually,
log a equals exponent of b, whatever the number.
you could, but that's more work than just dividing negative 2. Because then you have to do this to the negative 2 power. You will still get the right answer, actually. Yes, but it's very annoying.
The
So
whole thing you taught us before of moving into the exponent is just irrelevant.
in these situations, it is. But sometimes they're not. Sometimes it's simplification where you have to move it down.
This is simple.
This is similar. Yeah.
So now which one do you move? The 7 or the 5?
Now, everyone, please be quiet. This is the important part. Guys, for this one, log base 5 is going to go to the other side here. Log base 5 is going to be going to the other side. When it does, what it becomes is 5 to the negative 1 power. Very important. The base of the log becomes the base of the exponent. So the base of the log becomes the base of the exponent. So it's not negative 1 divided by 5. It's not negative 1 times 5. It's 5 to the negative 1 power. Well, 5 to the negative 1 power, I can rewrite that as 1 over 5. Then I have to divide it by 7 on both sides. So that becomes x equals 1 over 35. Remember, divided by 7 is the same thing. 1 over 35, yeah.
Wait, how is it gonna?
Ma?
Oh, because then you do
Yep. All right, another one. Log base 12 v squared plus 35 equals log base 12 negative 12v minus 1. Okay. For this one, they both have log base 12. So what's beneficial about that? Just cross it out. So then I get v squared plus 35 equals negative 12v minus 1. Now, I'm going to rewrite this to have all the v's on one side and set it equal to 0 because I'm dealing with v squared and v. So now I'm in a situation where I have to factor. So v squared plus 12v, 1 plus 35, 36 equals 0. So things that multiply to 36, that adds to 12. 6 and 6, so I could just write it as v plus 6 squared equals 0. Now I solve for each one. Since there's only one section, I don't have to split anything. V plus 6 equals 0. There's nothing to split because they're the same. If you had two different things, like v plus 2, v plus 3. So v equals negative 6. But before we could confirm that's an answer, we need to check something. We need to check if inside of the logs, does it cause to be negative? So I'm going to plug it into both of these.
Oh, wait, it's the log itself. It's not the actual number you get at the end, right?
No, it's the number you get at the end. If it's negative, it's a problem.
Oh, okay.
So in this case, I'm going to plug it into the first one. So the first underline is negative 6 squared plus 35. Negative 6 squared is 36. 36 plus 35 is 71. That's positive. Okay. We check the second one. negative 12 times negative 6 minus 1, which is positive 72 minus 1, which is 71. Both of them are positive. It's okay. So this is a check.
Same answer as well.
They're the same. Just because this is a simple one where the logs were just the same on both sides. Okay. All right.
Wait, don't go. I'm almost.
Get it down. Get it down. Okay. So now we're going to use some of their log rules in the equation, like the condensing. So this is where it pops up. So let's do log base 6 x plus 1 minus. Wait, minus. I guess we could do this one. Log base 6.
That's what I was gonna say. Is it a background X plus one or no?
No, normal size x plus 1. The 6 is a small x on the bottom. Again, typing looks nicer actually. X.
From staring at your phone. I stare at my phone all the time. With the reading.
Log base 6, 29.
No problem.
Okay. I need to condense these. When you subtract logs, when you condense them, they become what? Does anyone remember?
My contacts.
I heard it, division.
Next time I was on.
So I'm going to rewrite this as log base 6 x plus 1 divided by x equals log base 6, 29.
If you're not very confident, can you switch to different minutes?
I don't know.
Guys, yes.
Why don't I do log base 6 x plus 1 over log 6x?
That's not the same thing as what I just wrote. Those are different things. They become one log. When you condense, they become one log.
And divide them?
Because you condense them, they cause to divide. Yes.
Wait, is it 6 little? And I hate
6 is tiny, yes. Well, the 6 won't matter too much because they're both log base 6 on both sides.
No, that's what I was saying. Someone's
Yeah.
Wait, I think I know. Okay.
Yes.
Actually, this one makes sense now because if you do log 6 of log 6, like
Mhm.
basically it's the same thing, right? It's the same thing over the same thing. You can think of it like 1. It's not gonna affect anything.
Yeah.
X plus 1 over x.
Mm-hmm. All right. In this situation, we're dealing with a divided by x. We have no clue how to deal with that. So the best way to do is to get rid of that divided by x. How do you get rid of the divided by x?
Multiply by x.
Multiply by x. So multiply by x, cross out the x on the bottom. So x plus 1 equals 29x. Subtract an x from the other side. 1 equals 28x.
Wait, you only multiply and cancel out the bottom?
Yeah, because I want to cancel out the bottom. I don't want that bottom.
But why didn't it affect the top then?
Because they cancel out.
Is that it?
For this, I'm going to do one more example.
No, no.
Then I'm going to give you your worksheets.
Because I.
The worksheets to practice what we just learned.
That's not homework, right?
Oh, come on, man. You know the answer.
For one day, it's a Monday.
Yeah, no one's here. No
It's a
one's
Monday.
here.
I thought it's on the board.
Again, that's so rude when you say no one's here. I'm at least here when I hear it. Then everybody in this room is also people, you know? Yeah.
Why did it sound the board no homework?
Because somebody put graffiti up, right? You can't listen to that.
It was signed by you.
What is it? I don't even see what you're talking about. I thought you graffitied it, actually.
Oh, I have to visit my brother at the hospital today.
Good. Bring some math homework. Keep him busy. If he's at the hospital, he got nothing to do, so. What's up?
I'll give it up.
Oh, wait. I got to pick one more question for this, and then I'll.
Wait, do questions from the homework?
I've been doing that the whole time, yeah.
I feel like our test was this Thursday. I was excited.
What's the difference between ln and log?
LN is basically let's not.
Yeah, let's not do homework.
2. All right. So when you deal with ln, ln is a very special log. ln is log base e. Is log base e, basically. So if it's log base e, and there's no log on both sides,
It's for extra special.
so I move it to the other side.
Right.
I'm recording. Please stop bothering me. X plus 1 equals e to the second power. Just get out of the way so people see the sweeper. Yes.
Have you been recording this whole time?
Yes.
So the recording heard me say that?
I don't know what you said, but I'll probably hear it
About the
later.
homework?
The hospital brother.
Yeah.
I didn't know you were recording,
I've been recording the whole time. You didn't listen to me when I said I was recording in the beginning.
but I was listening to
When you deal with an E, you do not need to change it to decimal. You leave it in terms of E. So ln is actually kind of nicer because you don't have to do any math. You just put them next to each other.
Wait, what?
Like, you don't have to do E squared. If I gave you 4, you would actually have to do 4 squared or something like that. In this case, you don't even have to do the math. You just leave it as E. This is in the same section, yes.
Do we even know what he is?
What's up?
Oh wait, I think we discussed what he roughly was, right?
Yeah, it's, you remember, it's
Roughly 2.7.
7. The official thing is 1 plus x to infinity over infinity or something like that. Okay, worksheets here. 2 worksheets, you do odds. Pass this out to everybody. Worksheet A, worksheet B. You're only doing odds for homework. There's more if you want to have fun, but they're only odds for homework.